and set up of the gear, and we hope it works well. I hope I can display that my knowledge on all the fuel cells is better than my knowledge of setting up projectors. So, without any further ado, I've produced a little movie. It's about 20 minutes long, but it has a lot of cutaways and shows other vision that it would take me far longer to display to you. So, the best thing is let's play the movie and come back to it afterwards.
Hi Steve Jones, the author of the book Water Fuel Cell, Secrets Revealed. Steve, I think you're here today to let us into something. The secrets that are in your book. Tell us what you've been able to do.
Take a very basic concept of water fuel cell, develop a number of formulas and theories, and make the process repeatable, opposed to having an idea or a concept that really had no basis and people were just unable to communicate with others just what they achieved other than by referring to bubbles.
The fuel cell, what is it?
Well, it's basically a number of stainless steel cylinders or tubes, one inside the other, water filled, and a process of extracting energy from the water to run internal combustion.
So, what's the history of the fuel cell?
Well, I think initially it was discovered by a gentleman named Joe, who came across this phenomenon when trying to find some sort of water steam system to run his motor. Changed the shape of his cell until he came up with a format that seemed to work quite well.
So Joe was not able to bring it to any great degree, develop to a great degree.
I really don't know a lot about where Joe left it. I'm told, and I never spoke with Joe or met the guy, but I'm told that he developed interest in other fields and left the field. So, I've seen videos where he expressed that he didn't really know what the energy was or how it worked, but it did work. And that's what got me originally interested. It was a phenomenon that not only Joe but others had repeated and had results with people who made engines run.
So what have you done that perhaps others haven't done in the past towards the development of the fuel cell?
What I tried to do from the beginning was to create formulas, methods of measuring and methods of communicating, so that instead of saying to other people, bubbles, it all works on bubbles, which has been the case. When I get involved with this, people were charging cells, and primarily the service was all about what was on top of the water. I wasn't really happy with trying to work with bubbles, and it's pretty hard to say to somebody, look, my cell's working because it brings bubbles. What I did was look a little closer at the electronic aspects of the cell. What was happening when I charged it? What happened after I charged it? Did the voltage that the cell gave across it, did that diminish instantly? Did it take time? And what I found was there was a direct relationship between the decay of voltage across the cell and the state of charge. I was able to build a computer interface, write a program, charge the cell and then monitor the state of charge on the cell over what turned out to be many, many months. And then established that there was not only a relationship between the state of charge of the cell and the voltage that was across it, but it was a relationship that met the requirements of the formula. I was able to create a formula that would say, well, okay, do these measurements at these time intervals, and you can tell exactly how much charge is in the cell or isn't in the cell. You can also tell whether the cell is leaking, whether we've got problems where it's not holding a charge. And none of these things were available previously.
So what are the elements that are needed to have a working fuel cell?
Well, three criteria. The first is the water. The water's got to be the right water now. When I say right water, I've developed a method of processing that water, or any water, to be usable. The second is the construction of the cell. Needs to be constructed within certain criteria, the right sort of metals of the right thickness. And then the water's put in the cell, and the cell is energised by applying a series of voltages until we cause the deuterium hydrogens to migrate into and to dope the steel.
Okay, about the water, what's water out of the tap, or is there something special about the water?
No, well, it's not that it's special water. We just need water at the right part of the process. And although I explained that a lot more in the book, ideal water has often been called fresh or juvenile water. Now that's water that's virtually just rained and at the top of the stream somewhere. The problem with that is it's almost impossible to find. And even if you do find the right location, the water you get there is very different the day after a thunderstorm to the day in the middle of a drought. So what I tried to do was look at exactly what made water the right water. Firstly, it needed to have as little contaminants as possible, and we're not talking man-made contaminants, we're talking carbon-type contaminants. We need the water to have a reasonable degree of conductivity. Pure water doesn't conduct, and therefore doesn't permit the electrolysis, so that's not going to work. We need the pH of the water to be relatively neutral, slightly acidic if anything, certainly not as alkaline as it can be way downstream. What I did was to develop a process involving ionisation, where we separate the water from its normal 10 to 13 molecules into 6 molecule clusters. And in that process we're able to extract what we don't want from the water, being long chain carbons and pollutants. The process doesn't really affect the conductivity of the water or change the pH. So what it means is that almost any natural water, by that I mean non-processed water, can now be used, be it rainwater, stream, creek, river water. And any water like that can now be processed to the point where it's ideal for use in a cell.
Interesting. So the cell itself, what's about the cell itself? How is it made? What's it made of?
Well, many things have been tried. The best is stainless steel. There's no doubt about that. A good cell will be made of 316L, which is a low carbon, high grade stainless. The primary reason for that is that it doesn't deteriorate too much with the electrolysis, which is a prime part of conditioning the cell. We don't have problems with corrosion and rust. The main thing with a successful cell is having reasonably heavy metal. It doesn't matter on the cathode or the neutrals, the cylinders within the cell, but the cell casing itself either needs to be of a substantial metal or have a fairly good top, solid top ring assembly where the energy is taken off. The neutrals, which are the tubes within the cell, typically 1.6 to 2 mil is fine. It's reasonably important that the stainless is not magnetic. We really just will not get the results if it's highly magnetised, which is the reason they're going for 316L stainless. The other thing is that I found that the seams or welding in cell construction is a big negative. It really does affect the operation of the cell. Currently I use seamless stainless, and I find that is by far better. And a pressure assembled cell where quite literally the tops and bottoms are pressed in a fashion that we don't leak. And we have no welding, which affects the molecular structure of the metal, and therefore affects the energy that flows through it.
Mm-hmm. So then having the cell and the water, and obviously getting together, how do you actually get the cell to work?
That's a three-stage process. The first thing is to have your cell assembled properly and clean. To put in the charged water, where the water has been processed and electrically charged. When we first pour the water into the cell, we then go through a stage of energising the cell, which is applying a voltage for a given time and duration and at given intervals according to the formulas, the charge power formula. And we charge the cell until its half-life, which is another one of the formulas, until its half-life stops extending. In other words, we have a fixed half-life. At that point, tip out the water. It's always got contaminants in it, mainly contaminants from the surface of the stainless. Put in fresh water, and it's time to start using the energy from the cell in the running of the engine.
And is that all you need to do? Is sort of a sealed thing that the water contained in it lasts forever, or does it evaporate away? Or
the cell can't be sealed. We probably would wonder if it could, but it simply cannot. In electrolysis, we create gases. There's hydrogen and oxygen are the primary gases. Not a lot of gas, certainly not enough to run an engine in any fashion. Even the smallest engine couldn't run. So for people that think that we've got a hydrogen generator, not happening. Nowhere near enough. If we had no means of that gas getting out, there would be enough to create pressure and eventually the cell would explode. So we do have to have a vent, and that vent must be fed through a HHO or hydrogen flashback arrestor, so that the gases that are produced can be vented from the cell safely. And in my case, I always run the output of the flashback arrestor into the engine's inlet manifold and feed it into the vacuum, dispose of it quite nicely, and gets consumed in the engine. Having said that, I've done a number of tests where I've disconnected that vacuum or closed it off at the engine end, and I'm more than satisfied that it's having no measurable effect on the engine. We're not using any energies associated with the gas.
So here we have a fuel cell which is producing deuterium, which actually gets the motor to work. How does that get to the motor, and how does it work within the motor? Okay,
well, my theory is that at the point of electrolysis, we've got gases coming off of what are effectively the two electrodes, the cathode being the centre of the cell, the anode is the outer case. At the point where the gas is coming off on the outer case, which is positive, we've got oxygen gas being produced. And against the stainless steel wall of the case, we have effectively hydrogen-enriched water. I believe that the positive voltage applied to permit the electrolysis attracts the hydrogen, and when I say hydrogen, we're possibly talking deuterium, is being attracted to the molecular structure, the crystalline structure of the steel itself, and migrates through the structure toward the source of the voltage. Now, coming off the top of the cell, we have a connection device to the engine. For the most part, in the past, that has typically been a tube, 1 inch round, a fairly heavy worn tubing, where people were thinking there was a gas that was actually going through the tube, although that tube was not vented into the engine. It was going to a blind connection on the engine, meaning that at the point where the tube met the engine, there was no hole going through. We were simply presenting this gas to a blind plug. I then thought one more, and well, okay, is it actually a gas at that point? Is it travelling through the hole or through the metal? Another test that I did led me to the to the conclusion that it actually migrates through the steel itself. And one move on from the tube was the use of a head aluminium cable. They currently use about 14 mil outer diameter 19-inch strand aluminium cable to connect the cell to the engine. Now, we have a gap at the engine end, as explained in detail in the book. But what we do is we use the voltage which is connected at the engine end of the cable, and that attracts this energy along the cable right up to the point of the engine, where it travels over a small gap into the block itself, or the cylinder head. And then over time dopes the entire engine's metal with the hydrogen deuterium mix. And again, I refer to it as hydrogen deuterium because I really don't have a method of telling you exactly what it is. It simply fits with what I believe to be the operation of the engine.
Then, once this is within the engine, within the metal itself, how does it then work to combust air?
Okay, well, what I believe happens is a little different to many of the other theories being presented. It's just my theory. I believe that we end up with our combustion chamber effectively being totally doped with hydrogen deuterium, so that all surfaces are effectively wet with these elements. When we then combust or start to compress atmosphere, which is always sucking into the engine, just air, at about 2.5 atmospheres we then spark, where ignition timing is no longer a few degrees before top dead centre. It's around 70 degrees, and I've had an engine running at 85, so the piston's just over halfway up the stroke, the spark happens. That would seem to create an implosion. Now, there are suggestions, and I've read information that suggests that if we ignite nitrogen in a hydrogen-enriched environment, which is what we really have with air in this enriched combustion chamber, we get what is called an endothermic reaction, which is an implosion. Now, that implosion would certainly explain for the effective compression being removed, the fact that the engine can turn over so slowly and so easily. That implosion would draw the piston up and possibly also make the valves leak. In a normal four-stroke engine, valves are intended to seal under compressions, not under vacuums. So it also sucks in more atmosphere than was intended to go into the chamber. And the other interesting point with an endothermic reaction is that endothermic reactions consume the heat of the implosion. That would also explain why so many people have reported these engines running cold. Now, I personally had a readout of 70 degrees C on the exhaust of my generator. 70 is not that cold. You can put your hand on it, but you wouldn't want to leave it there for too long.
When you say generator, you're using what a petrol-driven motor on a generator as your test bed, are you?
Yeah, I've got a small Kawasaki 1500 watt four-stroke single-cylinder generator. I favour going for a generator situation because firstly it's easy to run the engine quickly. Secondly, because it's a generator, we can connect loads to it, and therefore we can measure the energies that we're producing and apply that to normal formulas of what petrol would go in for that amount of kilowatts out and so on. So a generator seems to be a poor man's perfect way of testing. Back to the operation of the engine, it would seem that if we've got an endothermic reaction happening, an implosion, that's pulling in more atmosphere than would normally be the case. When the piston approaches the top, there's a release of energy from that implosion. And I really don't know through what process, but an explosion definitely takes place. So we have the implosion at the bottom of or halfway up the stroke, somewhere around top dead centre, without a secondary spark, there's definitely an explosion. That is visible with watching the engine run the flywheel at low revs. It's also consistent with the fact that we still get exhaust noise. If we were running purely an implosion, it's unlikely to get any exhaust noise. Although it's fair to say there's a great reduction in the noise of the engine. It is a lot quieter running on cell than it would be on petrol. That could be explained by the fact that the explosion component is of a shorter duration than a normal petrol explosion. Most of the noise that we hear from a four-stroke engine's exhaust is in fact the exhaust valve opening and there's still pressure there. And that comes out through the valve and the exhaust and so on. In this case, there's quite a reduction in that noise. So that's basically how it works.
And is this engine running with petrol as well, or just purely on air, or mixture of both still?
Well, I have never managed to start the generator without petrol. I have to be absolutely honest about that. Some people have claimed that they have started and operated engines from cells alone. I haven't. It has always taken petrol. Having said that, it's a pull start. And there's a limit to how many times you can pull that string in trying to get it going. So I'm quite happy with the idea of putting a little bit of petrol in a much smaller than normal tank. And getting the engine running. Now I know exactly how long it'll run for with the petrol turned off. And there is little doubt that I've ran for much longer than that is possible. Not only witnessed by myself, of course, but many friends, neighbours and other people have been here and seen that. That's not really what I'm looking to promote. It's only fair to say that it's a very new science. It certainly isn't perfected. Anyone building a cell and going down this avenue would be foolish to believe they're going to build the cell, start the generator and run forever. We're not there yet. We're getting closer. With some of the formulas and methods of communicating, we're now in a position to further the science by exchanging what information we're learning as we go.
And so you've been able to develop a working model and demonstrate that it works. Where are you moving to from there?
I think at this stage it's a case of refining what I have established. The formulas seem to be consistent and working. There are certainly atmospheric effects of the motor. I haven't yet proven conclusively, but I find it almost uncanny that I can never get the thing to run on its rating. Now, it's not outside, it's inside. But there's certainly effects of humidity on the engine. So one of my directions is to look at the condition or conditioning of atmosphere as it goes in. As far as the cell's construction itself, we are exploring with the idea of laminating different metals so that we can obtain greater mass for the energy to go through while still having the stainless steel containers. Of course, that's always a dollar thing. It's expensive research. Another component that I would like to research is the concepts of incorporating a cell within a motor. Instead of being a separate device that's hooked to the motor, the idea of actually incorporating the generation of the hydrogen materials within the water cooling confinements of the engine. Again, something we're working on.
You don't know the equipment. Oh, it's warm in here. It's just me. Now, I'm hoping you've all got some questions for me. Gentleman there?
Yes. I presume when you run out of petrol, the engine's still running. Have you done an exhaust gas analysis and what are the results?
No.
The other question is, how the hell do you hand start an engine on petrol 70 degrees of advance?
You get no firing or no... You just don't get compression. The implosion...
No, when you're starting it first from coal on petrol.
Yes.
How do you start an engine with 70 degrees of advance?
You still with petrol. Once the energy from the cell
Can I
is...
rephrase the question?
Yeah.
I had a large capacity motorcycle which had manual advance retard.
Mhm.
And if I didn't fully retard that start, that is, didn't fire it until top dead centre.
Yeah.
If I had it on full advance, it was probably about 30 degrees before top dead centre, it would throw me over handlebars as it did on one occasion. So with 70 degrees of advance, how do you start the engine on?
About 85 or 90.
85 or 90 degrees. So much as how do you start the engine ignition on petrol?
You can never just have the engine on petrol. When I say I started on
Yeah.
petrol, we put petrol in it. The
Yeah.
deuterium is always present. So from the very beginning, we get an endothermic reaction and an implosion. There's no perceivable compression. When you pull the string, the plate's got in. You have no perceivable compression in pulling the string. It's simply, you get the inertia turning over the crank, the mass. You get to the point where the engine fires and it's as if the string gets pushed out. You've experienced this, Bob. Bob's been there many times when we've started this. There is no compression, and therefore, normally any internal combustion engine trying to idle at low revs with 20 or 30 degrees, the thing will just fire, the piston will get stalled, will go backwards. It won't run. With one of these, you can go from top dead centre back to 90, right? 90 degrees before top, halfway up the stroke, and the engine just turns over. There's definitely an implosion component that happens before the explosion.
And with the petrol present.
Even with it present, yes. Yeah. But I can't get it where I pull the string and it starts without petrol. I need petrol there initially to get the revs up. And it only needs to be enough petrol for the thing to rev, and then it can run out of petrol. But the problem is you can't pull it fast enough to get it to self-run.
A lot of those engines where you've got those full starts have got a compression release on it, so that you're not pulling on full compression.
Yeah.
So that as soon as it fires, that's when your full compression comes on, so you wouldn't build any compression at all, or otherwise you can be able to start that thing.
That doesn't have any sort of compression release.
That hasn't.
No. We have a book, which is what I'm promoting tonight, that has pictures of that very engine with the cylinder head on. You can see the valves, and it's quite easy to look at it. It's an old-fashioned, four-stroke engine. It's quite a few years old. It's not designed to run with the sort of advanced timing that it has. It shouldn't be possible. It simply shouldn't be able to idle. And the only way it does is because of an endothermic reaction, an implosion that happens.
You drive the LPG instead of petrol?
No, Bob's going to.
Not tonight.
Not tonight. We were hoping for tonight, but these things take time.
What's the relationship between your voltage and your amps and your unit? Are you finding that you're running small voltage, high amperage?
What are we talking in the cell?
In the cell itself?
That particular cell with the water I'm using, about 250, 300 milliamps, 12 volt.
Is there any other heating in the cell?
No, not at that power. It's only 3 watts or something.
What happens if you actually increase the amperage there?
You don't really need to. With a cell, and this is where a lot of people that have built water fuel cells or Joe cells, where a lot of them have gone wrong, is they've been chasing bubbles, and we don't need bubbles. And therefore, the amount of electrolysis we need is a fraction of what people thought we needed. We start off by putting charged water into the cell, so it's fully charged before we put it in there. From then on, every voltage that we apply to the cell is a conditioning voltage to get the deuterium from the water into the steel.
So then what about some of the cells where they're using sodium hydroxide?
Well, they're not working on deuterium, they're looking for hydrogen, such as whatever's.
Joe cell.
No, Joe cell certainly isn't looking for that. I mentioned in the video that the gas that comes off of one of these things is so minuscule.
Are you in a position to display the screen on the computer that shows the condition of the cell? You've got a fairly elaborate piece of software and hardware that enables you to monitor the cell each way.
Yes, but I can't bring, I guess I didn't bring my computer systems.
Okay, fair enough, yeah.
There was a quick glimpse of it on the...
I realise it was on tape,
Yeah.
maybe on the show.
I started off like everybody else did with Joe Cells. I saw something on the internet and I bought a book and I started off the hard way. And I went through and I got up in the middle of the night and charged water for 3 minutes, went back to sleep for 2 more hours, and like a lot of you that have played with Joe Cells, it's a bit of a commitment and it takes a lot of time. I then thought there's got to be an easier way. So I built a computer interface. I then wrote some software that could do variations on charging. And what I realised was there is a relationship between the residual voltage in the cell and the conditional or the charge of the cell. So I came up with what I call a full life and a half-life formula. Now what that means is that we can charge any cell with any water for 1 minute, just straight 12 volts, and then we can measure that voltage 1 minute later, and that's called our full life voltage. We can wait another 4 minutes and measure what that voltage has dropped off to, and that is our half-life voltage. Now, every time that we charge the cell, and we do that in accordance with another very simple formula, every time we charge the cell, it takes longer for that half-life voltage to drop off. So initially, because of how the formula worked, it's 5 minutes. But it's not long before it's 25 minutes, and then it's an hour. So we're charging it the same amount of charge each time, but the duration between the charge gets longer and longer, and that's to do with the surface charge, the material in the surface of the steel being absorbed into the crystalline structure. So it's quite an interesting formula. What it does, it takes all the guesswork out, and all of you people that have charged looking for bubbles, this simple formula will get those wonderful bubbles within a day or so very easily and very repeatedly.
Do you find that the effectiveness of the Joe cell increased with the engine load applied?
Sorry,
with the load applied to the engine?
No, I can't say I've really tested that.
Could you repeat the questions on the mic, please?
Oh, okay. The gentleman asked whether there was an increase in effectiveness of the water fuel cell on the engine when a load was applied to the engine. It's not something that I've tested to date. I always run the generator. I say always, that's not true. Most of the time I run the generator with a load. You saw in the video a little 250 watt halogen lamp on the generator. The reason for that is that even the fuel with the carb in one of these things will make it run for several minutes without load, idle. You don't use a whole lot of juice.
Well, I'll tell you why I asked that question, because when I experimented with the Joe cell, I was expecting the car basically to run and idle on like most people do, and I was able to increase that was on a 1.5 liter engine, the idle time on just one float chamber content to about 6.5 minutes, when it normally is about 1.5 minutes, which I thought that was pretty good. But
Yes.
I was never, when I was trying to run the engine, then under load I wasn't able to turn the fuel off until one day when I was going at 100 kilometers an hour and I had reasonable load on the engine, and it just occurred to me because I had a fuel cell, I wanted to just turn it off.
Yep.
And it would then keep running, and I drove for about 10, 15 kilometers. And then as soon as the load dropped below a certain level, then I had to turn the fuel on again, because it would only work above a certain engine load, not below. So I was able to actually drive with the fuel up inclines and up the freeway and all that.
Okay.
Not actually driving under low load conditions, and that was with a severe advance on the distributor as well.
What sort of time were you advanced?
I don't know, other than I know that I had to actually machine the foot of the distributor away because the slot wasn't long enough. So it was way past that.
Carry on.
But that was after quite a while. Initially, there's no way you can get the engine running. That was after the cell was on there for quite a few weeks.
So you had advanced timing, but you didn't have any problems with it pinging or
No,
having trouble with it firing?
No, I did not. But that was after, I mean, no, it takes conditioning time, but it would only really work under above a certain load. When I was doing about 65 kilometers an hour, constant, I turned the fuel off and above, but not below, which is counterintuitive to what you would expect. That's why I'm asking the question.
There definitely seems to be a change in the air requirements of the engine. A short part of the video there, I didn't think to make it obvious.
Because it draws a lot more air than those conditions, so maybe it needs more air.
It may not be more air, it may be less air. When you look at the load situation and the fact the carb is open. On the generator here, part of the filming that you saw it running, there was a thumb almost nowhere over the carby. That was Bob Cox's thumb, blocking off the air intake to the carby. Now, normal generator revs, load on it, and the carburetor virtually blocked off. Choke butterfly closed. Bob's thumb, which is bigger than mine, his thumb was able to fit the whole hole. Virtually no air going into this engine. It shouldn't have even been able to run at those revs, and yet it did. And it would not run with normal air going. Another strange thing that happens to me all the time is the petrol won't flow into it. Doesn't matter what I do, I cannot get the petrol to go into the carburetor. It's like it's blocked, but it isn't. And that seems to be when there's too much energy there. It just repels the petrol, it won't flow. But we're getting there. Okay.
Another question. You've got the 250 watt light bulb on it most of the time, and I've seen it myself. You say you have about 6 minutes worth of fuel in the carburetor. I don't use
It's about 3, actually.
Okay. What is the maximum time the machine has run powering that lamp once you've shut the fuel off? People have heard that.
I'll say an hour, because many people have seen the hour. It's longer, but an hour is and to me, for something like this to run for an hour without a fuel tank connected is pretty conclusive. It'd be lovely to go and buy an exhaust emissions analyzer and all this wonderful equipment that I just don't have. Otherwise we'd be showing graphs and all sorts of things.
I'll let you one of them. I got a 5K analyzer.
Have you? I could use that. Talk to me later. Yes.
Have you thought of any way how you might concentrate the so-called deuterium in the water before you actually start electrolysing it all, or anything like that?
I don't know there's a need to. When you charge water repeatedly, keep charging it, it becomes heavy water, deuterium enriched water. And that really seems to be enough. But when we put it into the cell, the actual electrolysis that's happening in the cell is also charging that water and creating more deuterium. So how do we get deuterium? Well, we know that all natural water has it. It's just there. We know that when we charge water through electrolysis, we create more deuterium. Now, the only difference between hydrogen and deuterium is an extra neutron. We do know that in electrolysis, we're separating hydrogen, effectively oxygen. Oxygen's got 7 or 8 neutrons. Someone will tell me. 8, thank you. I don't get these numbers. I'm an electronics guy. Some of this stuff is just beyond me, but you have to learn it if you try it, for sure. So we've got all the components to make deuterium, but I think science is quite happy with the fact that we do it by charging water. Another thing is an idea of how much deuterium do we need for it to actually go through metal. I'm talking, did you have a blind connection on your engine, or did you go to the inlet?
I had a blind connection to just an aluminium block with about a half-inch stud on it, and that's where plumber holes was.
Okay, so the energy is going through the metal itself. How much do we need? 1/8 of a gram of deuterium is the equivalent of 1,200 litres of petrol. So it gives you some idea of the bang that you get in deuterium. Now, on my engine there, away from the microphone, but that's a blind connection, there's no hole. Okay. I do feed vacuum to the cell, and this is typically the cell that was on the roof. Come back to the microphone. I feed a vacuum through this very, very small diameter tube. Occasionally I block this thing off and do all sorts of tests to make sure that we're not running or having anything to do with the gas that's coming out of here. Very little, but it's there. No more tubes, this is solid cable. Okay, so we're actually connecting to the engine via a 9-inch aluminium cable, and that energy is going through there. Ian Pagan, some of you would know from Newtech, put one of these exact cells on his car a couple of days ago. There's a video on YouTube now. He did tests on this little Corolla, which hadn't had a cell on it in the past. He ran it many times and got 90 something seconds repeatedly by switching off the fuel. The first thing he did before he put a cell on there was put a fuel cut-off solenoid. Started, ran it, turned off the fuel, timed it. Repeated and got exactly the same time. Then he put a cell on there. In his case, the cable is way long. Hooked it up, a couple of energising charges, then turned the fuel off and got 4 minutes and 5 seconds.
And it's idle.
Idle, just idle. But it's from 90 something to 4 minutes and 5.
I had from 90 seconds to 6.5 minutes.
6.5, well, you did better than Ian. Ian's been in the game for 10 years, never had those sort of results, so he was pretty happy. It was a long phone call. So it happens, and we're slowly getting there. What I've managed to do, and what the book is about, is to try and remove the reliability on visual effects, remove the fact that we're looking at bubbles, and put consistency into charge, where we have a charge power formula. The gentleman asked how many amps and how many volts. Every cell should be charging at about 0.5 watt per square inch of cathode. So with a simple power formula, it doesn't matter how many amps or volts, as long as you end up with about 0.5 watt per square inch of cathode. Any more than that, you just etch the cathode, you let it. Any less than that, you'll still get there, it just takes a lot longer. So between the power formula for how much do we charge, and all charging is based on the idea of 0.5 watt per square inch per minute. So if your current is 1/4 watt, you charge it for 2 minutes. But if it's 1 watt, you charge it for 0.5 minute. So a very simple formula of saying what is the right charging current. Now where people like Alex Schiffer used to say charge an amp, now an amp is great, but if you've got a 6-inch by 1 cathode, you've got 18 square inches. If it's 10 inches by 2 inches round, you've got 30 square inches. Is that right? Yeah, somewhere around there. So what I've tried to do is bring down some constants so that I can charge this, and I can tell any of you exactly what my charge power is and what my half-life is, the time it takes for this cell to deteriorate to that half-life voltage. And you can repeat that exactly. And you can share your findings with others and say, my engine's running and I had this half-life. As far as bubbles, read the book. You don't want them. Bubbles, how do we get bubbles? We're going to put this down there. That's about the latest in cell design. It's seamless. Well, actually, that one isn't, but the ones we're making over now are 2 mil seamless, and the finish is almost like chrome. They're just mirror finished. That stops etching, and it really stops dirt building up in the cell. They just go for so much longer. Now, as far as bubbles, how many of you have done Joe cell stuff? Okay, that was a few. You've all gone through looking for these wonderful stage 1, stage 2, stage 3s.
Could I interrupt for a minute? The owner of XEH153 and XDC375, could you move the cars for a moment, please?
Way out the road.
Because the meditation group was on the next floor. You're packing them in. Thank you.
Bubbles. I looked into bubbles. How come when I did my half-life testing, I did my computer modelling, and I got all these results. I got them whether I had bubbles or I didn't have bubbles. So then I looked into what could make bubbles, and I did a little research on where does the rain come from? How does it happen? How does it fall? What happens to it? Turns out that all plants, or almost all plants that have leaves, have an immune system. That's the reason that fungus and mould doesn't grow on a leaf. It grows on the ground, not on a leaf. they secrete what they call a sapion, which is a natural form of surfactant. It's another word for soap. So all of this rain that we get at the top of the mountain stream that's come off the rainforest, that's come over the paddocks, has picked up all of this natural soap. And it just happens at that stage to have not too many pollutants and to meet a lot of our other requirements. But we've got this soap. And when we start using that water in these cells, we get these bubbles that seem to look great, and they work. They do absolutely nothing for the production of the energy or the operation of the cell. So
it's sort of back to the half-life of the time power for the course of the shower system.
I don't know, you could call it material generating battery. Certainly not electrical battery. It's good for no current, but yeah, it does accumulate deuterium. And sorry?
The half-life you talk about was the voltage.
Oh, when we're talking half-life, we're talking purely voltage. The residual voltage, when we put a charge on a cell, right, we'll stick 12 volts on it for a minute, and we wait a given period of time and we measure that voltage. Now in the case of this cell, it varies from cell to cell, but it's pretty consistent with a particular cell and a given water, because they all affect it. So that cell with the water that I've processed, that I use, the half-life voltage is about 1.2 volts, which means when I've charged it, I'm not going to charge it again until the cell's voltage has dropped off to 1.2 volts. And this is a very simple formula that's in the book where you do 2 initial readings, you get the full life voltage, you get the half-life. The full life is the 1 minute after a charge, and this is initial charge when we first put it together. When you connect back into one of these cells, the voltage on it will go up to the full life voltage. It's kind of uncanny to watch, but all of a sudden you've got this thing going up in voltage, not down. And now the very, very crazy thing is current can come out of them, not into them when you're charging them under vacuum. If you've actually got an engine running, the generator's running off this and the computer connects to charge, I often get the current coming out, not going in. So just another novelty.
If surface area of the cells is what's creating the volume of hydrogen, a friend here has got the latest design of a cell with square plates. So you're getting more surface area if you're going to put square plates in rather than the round plates. Another question I've got is a more exotic metal, wouldn't that encourage the hydrogen to be produced? In other words, if your plates in there were plated with, say, nickel, the nickel is going to encourage more hydrogen production.
Yeah.
The other thing that's amazing me, you're charging the water. Is it possible that you're restoring the memory back in that water?
That I don't know. I really haven't looked into the memory storage part of water. I've watched the videos, I've seen the crystals growing, etc. I haven't researched it. As far as the square plates or flat plates, the reason that we have the shape we do with a water fuel cell, this is a bob cell, we've got cylindrical cylinders one inside the other. Each of those effectively becomes a battery. Okay, we get, when it's fully charged, about 800 millivolts across each of the gaps, and half-life's about 400 millivolts at each gap. That battery that's inside the cell tends to stop that battery that's in the cell tries to stop the deuterium from returning back into the water. So what the neutrals actually do act as a barrier to keep the charge within the cell. So if we go for square plates, we really don't have the same setup and we can't keep it as charged. Having said that, you can put an external control voltage on it and keep it charged without neutrals. You can build one of these and make it work without neutrals. It's just harder.
In that square, you get a dry cell setup with as many neutrals as possible.
Yes, you can have as many neutrals as...
No, I mean in a square plate configuration, configuration. And they're all separated from each other. So
if they're flat parallel plates, the problem is that we're accumulating deuterium on one plate on one end only, and we need a mechanism to attract that off of the metal and out of the environment without going back to the cathode. The construction of this is just ideal for doing that. When you're in a flat plate environment, you really can't stop that, and it's much harder to stop the cathode, effective cathode end plate from leaking through all the others. Unless you try to convert a Bob Boyce cell or something into a Joe cell, but it's not going to work as easily with just a simple format there is in one. What was the other part of your three?
Yeah, the nickel plating.
Never looked at nickel.
Have looked at nickel as a very exotic sort of material, and it does encourage, in certain conditions, gas production.
The nice thing with stainless is that when we get to these mirror finishes, we don't get etching. It's a fairly dense metal. People have had a lot of success with aluminium, especially aluminium tops. Anyone here made an aluminium cell or an aluminium lid top cone? Nothing? You have. You have. Okay, you both have. Well, you've had success. Did you have any success with yours? No? Okay.
Seems to be actually the key to it in my case.
The key was the aluminium.
Yeah. Aluminium top.
The advantage of aluminium is that being such a soft metal, the deuterium enters it and migrates through it very easily. As for the angle, and I've heard a lot of people talk about pyramid tops, cone tops, 45 degrees. I've bought them, I've made them, I've tried every one of them, and I haven't measured any difference to a flat top. Now, I'm not saying there isn't a difference, but personally, there's been no operational difference for me personally over a straight flat top, and the flat top's about a tenth of the price to make as even something like one of those tops, which is 8 mil thick. A lot easier to make. The direction that I'm starting to go now, and Bob and I were talking about this a couple of days ago, was laminations, where the water surface is in contact with a 1/2 mil of stainless. That's there for the electrolysis to stop corrosion, etching, and all the things that aluminium has. But literally, aluminium bonded to the stainless, so that we've got the lower density structure for the deuterium to migrate through. It's just a case of getting the numbers right, getting the thickness right, getting it working, and you've got to try these things.
What was interesting was the aluminium tops which I made, because they were solid machine tops, they were press tops. That after a while, the cell was operating for a while, the actual aluminium cone part that was subjected to the inside of the cell formed a almost black sort of anthracite coating on it, which is very hard and it's non-conductive. It was not aluminium oxide. So, and that was also when the cell was at its full effectiveness, and when it was once this coating formed on it. Never quite what it was.
But some grains of aluminium, you've got copper in it, whether you're separating the copper from the aluminium. You find a lot of
green.
Sorry?
It would be green. And this was totally non-conductive. So it was black, it was not green.
Actually, matte black,
No, matte black. It was like cardboard.
Yeah.
Excuse me, Lou, was that with the carbon centre?
Yes, it was. Yeah, I had a graphite. Actually, I had a graphite center, and then stainless tubes around that.
You have no neutrals?
Yes, I had neutrals.
Neutrals are graphite center. What I would invite all of you to do that have worked on Joe cells within 1C, share with me, if you could, what successes you've had and what variations. I spent some years in my shed knowing nobody that worked with these things. I read little bits on the internet, came across Bob absolutely by fluke buying some tools one time, and got to know him and therefore meet some of you and others in the field. But I've had very little hands-on with other people's views, and therefore things like the aluminium tops, the carbon or graphite centres, they're things I haven't explored because there's a limit to what I can do in a day. But I'd like that feedback. I don't need to reinvent the wheel. If you tried something that didn't work, it saved me a lot of time. If you tried something that had positive results, help me get into that direction. At the end of the day, we all try to achieve exactly the same thing. Now, who was it? Someone bring it up. Yes, sorry.
What colour is the spark plug showing on it when it's running? Is there any coloration? Is it a brown or maybe a solid?
That one's black.
Black?
Jet black.
Right.
Because I run it out of fuel, I turn the fuel on, literally put my hand over the end of the carburetor and pull it a few times. So the first time I turned the ignition on, she said we should flood it, it's not funny.
The only reason I was asking for is that you know the motors that they're running perfect steel rings, or they running just conventional rings?
Sorry,
They running perfect steel rings, or just all everyone runs conventional rings?
that's just, I don't know. I've never had the piston out of it. I've had the head on.
Conventional rings, and what I'm asking is if on that implosion that you're saying, is that maybe it's pulling a fraction of oil vapor up, that it's actually partially using that as
Yeah, I have little doubt. Well, I don't know about these kinds of fuel, because the oil level certainly does not go down.
It's so minute though, that's what I'm saying.
If it's that minute, I'd gladly buy oil instead of petrol. You know? It's 4 litres of GTX will get me 100,000 Ks on your month.
They the combination with what's you were saying about the starting problem.
Yeah, it could well be, and with an endothermic reaction where we've got this implosion, and I think that's really evident by the fact no compression. The gentleman here said that it should be kicking back. Just occasionally, I've seen it, I would have seen it, I don't know whether Ken's seen it. Occasionally I'll pull it, and this is like 1 in the 100th ball, and it kicks back, and boy, you know about it. It's enormous, it's huge. Most of the time, there's just no compression. So that implosion that starts must logically take oil past the rings. We must be consuming some oil, but I've never had to replace oil in the at all.
Well, I just recall that when Bruce there, or you were there, when I gave my cell to you, and you might recall tell the story what happened to your car there with the oil there.
Yeah, when the cell that Lily gave me, when I used it on the car, the actual exhaust went really oily. It was that bad that when I pulled up the traffic lights, you couldn't see what was behind you. It was as though, similar to if you break a ring, crack a ring or something, it was that much
The
oil.
implosion was sucking oil up past the rings and burning.
Yeah, but the interesting thing was that Joe had said previously that if you're having any problems, get a lead, go from the positive of your battery and just arc it onto the block, and it will get rid of the charge. And I did that, and instantly the oil smoke stopped. But it came back over a period of a couple of weeks. It came back again, and I arced it and it went away again. In the end, I took the cell off, and it still did it. And it was only after I drained the water out of the radiator and the block and put fresh water back in that the oil smoke problem didn't reoccur.
Well, firstly, thank you for telling me that 6 months ago, because you saved my van. I said to Bob Cox, who came over one evening, probably 5 or 6 months ago, I'd had a cell on the van, not for a long time. We'd done a couple of trips. And I took the cell off the van, and a couple of the effects didn't go away. It used to go into silly idle mode. Idling at, how many RPM, Bob?
Possibly 200.
Yeah, just way lower than it should have been, to the point the ignition light had come on. So at the light side, it's already going. And it did this wherever it felt like it for a long time. I couldn't stop it. I just could not stop this thing from dropping off into absolutely smooth, so smooth, smoother than normal 800 RPM one. Just down it goes. And Bob's got his head under there, and he's got his ear on the exhaust pipe, and it's running as smooth as can be. And I think, Bruce, you were the one that told me to zap the crank. And I did. When I zapped the crank, it idles normally. So thanks for a normal vehicle, Bruce. Anyone else?
316 stainless, by the way, has between 3 and 6% copper in it.
Okay.
So,
Could be using that. What we're doing is well, Do we need to use anything else? We believe deuterium is our energy. It certainly has enough energy. Gee, an eighth of a gram for 1,200 litres of petrol, that's pretty powerful stuff. I've got another video there, which if you wish to see, it's 10 minutes long. It was a presentation by Barry Hook. It looks at the Joe cell, and perhaps back in the early days, he spent time with Joe and had access to Joe's cells. Talks about what he found. He concluded that it may be deuterium. That's how I originally got on to thinking about it. And then when I learned about endothermics and so on, it fits. But he also talks about the power of deuterium. 1,000 times more energy in deuterium than uranium. Which is powerful stuff. You know. It's about 1 million times more than petrol. It's some crazy formulation of energy, but you don't take those as literal numbers. It's just the proportions are enormous.
Yeah, but I'm just trying to make some sense of the physics and chemistry of this. Yes, there is an enormous amount of energy in helium, but that only when it fuses to form helium. And we're talking about a reaction that normally takes place at normally high temperatures. Atomic bomb, hydroponic bomb treatment, so it's a lot of, and fusion, experiments with fusion have been very difficult. They use all kinds of things like that. And just getting back to trying to make some sense of this, the only way I can see deuterium being formed is that you get atomic hydrogen that is not molecular, but atomic hydrogen formed initially, normally in the presence of other hydrogen, which is molecular hydrogen, that is H2. It would then need to combine with an electron, for example, a neutron, which then somehow or other must join on with another spare hydrogen, presumably another atomic hydrogen. The net result of that should be a net positive charge on the cell. Have you noticed that? The other question is, the other thing I'm trying to figure out is, the only way I can see this running, unless we go for a fusion reaction in the internal part of the engine.
Or is it cold fusion?
Yeah, sort of the cold, well, anything under 10 million degrees is cold fusion. So that's often cold fusion, if that's the case. My other thing that's got me thinking is perhaps it's actually catalytically combining nitrogen and oxygen.
That's more than likely.
Yes, so that's why I asked the question about exhaust gas analysis. So
I don't have the ability. There is, I didn't bring it, in the Barry Hilton tapes, he talks about all the guy's name, experiments on HHO type generation environment, where they were able to, and they measured 350% increases in helium in the exhaust over what were in the carburetor. So there's helium generation, which supports all the rest of it. As far as creating the deuterium, I think it's just accepted knowledge. The Germans did it in World War II. You just keep charging water, you get deuterium.
That was the conventional electrolysis of water. It was done in Norway and hydroelectricity. And so there seems to be more deuterium that comes out. And then you burn that for water and you put that through a conventional electrolysis. The amount of deuterium in mattress water is extremely small. A few parts of it by the leaves.
That's there, but we don't think we can make deuterium. Well, for starters, all we need for deuterium to occur is an electron and a neutron.
Well, we have to combine those and then latch them on.
Yeah. So right on the wall of our cell, we're separating hydrogen and oxygen. Oxygen's got the neutrons. We've got heaps of electrons.
Well, that would leave a radioactive or an unstable isotope of oxygen.
Not necessarily. Deuterium oxide is
No, I'm talking about you end up with oxygen with a negative weight 15. I don't know if that's a stable isotope or not.
I don't know either.
The most likely.
You're on the limit of my knowledge here. I'm a humble cell builder.
My guess is coming from the electron.
Okay.
That was supplying from the original charge.
Don't know. I really don't. I mean, if there's specific questions of that type, I'm happy to Google them and try and help you work through them. But to be truthful, it's not. Chemistry is not my field. I didn't know what deuterium was until you were about. Never heard of it. It's something where you hear, you look, you Google, you live on the internet, and you research. How do we lose compression? Endothermic reactions give compression. What can cause that? Then we work back to somebody else's suggestion, deuterium and nitrogen. So you get it from both ends. And the other thing is, and I'll grab one of my books. This is the book. Don't even mention this in the book, and didn't dawn on until we're just talking. This is processing of water in a fish tank. It's an ionisation multiple charging process I came up with that gets the water just right every time. One side of the tank is always about 10% higher in water level than the other, but there's a hole between the two halves. So one side's about 10% heavier than the other, and deuterium happens to be 11% heavier than water. Kind of supports that we're making it. And I don't know why I didn't think of that when I printed the book. It's not a mention of it in there, but I've seen it 1,000 times. So,
there's a sort of unexplained scientifically unexplained things happening with electrolyzed water, which is something that has come back from US, and there was an article in the local paper there in Wichita that the hospital is now using electrolyzed water as cleaning agent. There are many other cleaning products, and they find that is the best cleaning thing that they can use. It just basically removes everything.
Ionizers, which is what fish tank is in part of ionizers, we have a membrane with an electrode either side of the membrane. Can't be that boring. With an ionizer on either side of the membrane, and what we do is we basically break down the water molecule from 13 modules down to 6. Now, we end up with a proportion of those molecules that are alkaline, and the others are acidic. In Japan, in all hospitals, they drink the alkaline water. They prepare it, you can buy machines for it, but it's standard that they drink the alkaline for health purposes. You go to a Japanese hospital, no tap water, it's alkaline ionised water. And they clean all the hospital stuff with positive water.
Yeah.
So, yeah.
When you were running on the engine, did you record any temperatures of the head?
I don't have a thermal gauge, I guess. I had a friend that turned up with an infrared thermal gauge. He stuck on the exhaust, it was up 70 degrees.
That's just a head on.
So,
As far as the head is, well, off 50.
no, you can do it. You do it well, the highest point of the combustion engine normally is the exhaust manifold. That's where the flames are coming out. But in the case of the air cooled, there's so much air being blown over the head, the fins aren't getting a real combustion surface temperature anyway. Normally, you touch an exhaust just for a second and you've got to burn. She's up at 730 something. Someone can tell us what the exhaust point's at 730 something on petrol.
Depends on the load.
Yeah, okay. It's hot. It's not 70 degrees. Having said that, you don't leave your hand on 70 either.
Did you measure it at the outlet of the exhaust or at the manifold?
Just in front of
70 degrees right there.
Would be about 200 normally. 200 to 250 would be normal.
Well, 70, you can touch it. I was quite surprised actually. When I saw 70, I thought, is that all? Ow! 70 is quite warm when you put your hand on it. But it's still way less than it should be. Now, how do we not have the heat? Endothermic reactions absorb heat. Okay, they take in the heat of the reaction. Personally, 70 is the only factual number I have, the best I've seen. I've read what I believe is credible information from people talking about frost and exhaust pipes. Engines running so cold that they frost. Now, if I can get down to 70 when I shouldn't be, I can't dispute somebody saying they've been right down the other end. And if we've got a full endothermic reaction that's consuming all heat, it can also consume ambient heat and we can get down below it. So, can't dismiss it. Yes?
Yeah, a couple of questions just on the cell itself. I gather that top cap is actually isolated from the other tube, is that right? Or,
The top of the cell?
yeah,
No.
so that's
Part of it.
has got a metal contact with the outer tube.
In that actual instance, it's got a rubber band in there, which I don't normally have in there. Okay, I'm showing as a whole assembled. Because of the clamp that goes around the outside, this is the easiest cell. That's the top. And that's got an overall seal. But from an energy point of view, we've got this wide battery stainless cast touching all surfaces. So we've got a conduction point in the same way our energy's going through the cable and everything else. There has to be points where things touch.
Yeah. One question is, you've got two neutral tubes in there.
Yes.
Is there any particular reason why you've only got two and not three or only one?
I don't think there's a need to have more than two. All we're doing with neutrals, Barry Hilton's work found that he couldn't see a reason why we have neutrals. As I explained earlier, the neutrals are little batteries. There's about 400 millivolts of half-life on each of those neutrals. What that potential is doing is keeping that material in the metal on the outside. If there's nothing else to stop it, if there's no potential, it's just going to come back to the cathode and back into a natural balance. The electrons are also going to try and get back. So they just help keep the balance. Now, having said that, I've got a step further this week. You're familiar with the fact that you have a gap at the engine end of your hose pipe or cable or pipe or whatever you connect with. Did you have a gap on the tube to your engine? Okay. We don't have a gap here. We can connect this cable absolutely directly, hard connected to the block. Now we used to have a gap because 12 volts went on here and the block's at ground. But what I found this week is connect that solid and put a negative voltage on the cathode. Separate supply. Positive to the block, negative to the cathode. So we're running this on a floating supply. We no longer need that gap, and boy, does the energy get out quicker. It makes a huge difference to the way things work. So just one little simple step. That's not even the book. The book's not a month old, and already we're saying, hey, there's more.
But the reverse polarity of the cell is going to be the same?
No, leave the polarity exactly the same. Instead of having the negative of the cell going to the car chassis and 12 volts fed up here, we have a separate supply where we put the positive here, which happens to be connected to the engine, and now the cathode, which is the negative, doesn't go to the chassis anymore, it goes to the negative with our separate supply. So we're floating the whole cell out and connecting the positive opposing to floating or grounding the negative and floating the positive. Just makes the connection. Well, the J-car sell $24, 12, well actually it's a beautiful difference. It goes from, I think, 6 to 12 in and 6 to 24 out. So if you want a little bit more voltage, I believe it's a switch mode float. Don't quote me on that. You have to get the, I just logged on for Ian and he said, what can we do in a floating? If it's not a floating, it certainly would have to be switch mode. I couldn't see why we couldn't make it. Yeah. This is the man to see for the floating power supplies. Anyone else? Yes.
Over the period of Joe cells, there's been a lot of talk about insulators. Can you just tell us what you found to be the best?
With insulators, first we don't have external insulators. Okay, you don't have insulators between this outside neutral and the cell. That's a big must. Make the cathode support strong enough to take everything without having one here. Ebonite is I think probably the best. Having said that, I promoted Teflon and made Teflon, even sold Teflon for some time. There's really not a lot between Ebonite and Teflon in an electrical and insulating point of view. Insulators, by the way, people think of the insulator breaking down electronically. It doesn't. If you look closely at where it's etching and how it's etching, I think it's the deuterium seeing a way back to the centre to balance things back up. And there's no cell potential there, as in the water, the electrolyte is simply not where the electrode is. or where the insulator is. And that's why they etch where they shouldn't be etched. So Teflon's great, it does hold it nicely. Ebonite really bonds. If you put them together with ebonite, it's impossible to get them apart. You literally get rubbing over them. So, is that it?
What about when I first met you talked about your band? What particularly else happened to that?
The band? I don't like talking about my band. I don't promote these cells for motor cars. I have to be very honest. You won't see anything in the book that says put it in your car. I don't think the technology is reliable enough yet. And if it's going to pack up, it'll be mum and kids on the road I want. It's all right for us to have our own experimental vehicles, but occasionally someone else uses these vehicles. Humidity is a major thing with a cell. If it's raining, a running cell will stop. I often can't start that if it's raining. And I think humidity is something, I'm now looking at how can I dry air, how can I make this test and overcome this problem. I put a cell in the van, it's in the book. And I drove over to Meadows, which I had several times. Now, my old van is an 84 camper. It's a 2-litre high-ace converted to a camper. It's pretty weak. About 40 k's is the best I ever got up Chandler's Hill Road. Second gear, absolutely flat out of the ground. Put the cell in there, went up at 60 k's, top gear, tried to overtake traffic. And I don't know why. It was the day I put it in there. It was instant.
How far did you drive?
There was a need to say, wow, let's go. It was fun. We then drove up to Monado Zoo, never intending, had the cell on board, had fuel on. Not even thinking about the cell. I've got my folks on board, wife, son, we're going to Monado for the day. So up we go to the zoo. When we came to the zoo, I'm running out of gas. So I flipped the switch and didn't realise that, and suddenly it ran smoothly, not actually in the middle position, it wasn't on petrol or gas, and I didn't pick that up till I got home, about 100 kilometres later. And on the way back I did comment, without even thinking fuel, this thing's flying up and down hills. Now, on that realisation, I went from sceptic to amazed. This really does happen, there's something in this. Cell came out, went on the bench for lots of experiments, and my friend at Meadows that I was going to see on that day, he owns the generator. Take my generator home, he said, an experiment. 3 years and about 1,000 pull or 10,000 pull starts later, I've still got his generator. One day I'll buy electric start. But the reason I've still got that generator is I know absolutely everything that it does. The timing on it is a machine slide. Pull the lever, that's top dead centre. Well, actually, it's about 30 degrees before, and that's around 9. So I know by looking through the window exactly where the timing is, I know the quality of the river, everything. When something changes because of an experiment, being going from tube to cable, I know exactly what the changes are because it's run hundreds and hundreds of times consistently. If I go buy a whole new generator, I'll put a new benchmark. Did you want? No?
You're going to have trouble when once you get involved with somewhere like Newcastle, unless you find a loop.
I think that drying air is not a big process. Drying huge volumes of air can be a little harder. But as I mentioned earlier, with Bob's thumb over the carby, a couple of millimetres of hole at the very, very most, and the thing's running the lights, full revs, everything goes. So maybe these engines really just don't need the air that they're getting. We might need a lot less air. Perhaps we're running on the super rich end of things. And it's only been, since a week and a half since we did that, we started up with, we couldn't get petrol. Bob came over, we said, let's start the generator. Couldn't get petrol to go in. No blockages. Just nothing I could do to get petrol to flow into that carburetor. And that's happened before. Build up of energy, whatever, won't go in. So I said to Bob, let's put our thumb over the carby, block it off, it'll run nice and rich. We really never did run rich. We could only get the engine to run with the carby blocked off. Just Bob's big thumb. That's what the photo was on the video. And it ran. So, yeah, part of this development is we need to condition air.
We need explosion warnings to come with this.
This is my shed roof, garage roof. What's more, it's asbestos. It's going to cost me a fortune to get it replaced. Yeah. Have a hydrogen.
Explain why that happened.
Well, Bob over here said, let's have a coffee while the cells are
No, we were just doing lots of crazy tests. It's all right to talk about what you refine, but occasionally you look a cell up to and you leave it all, and you say, well, what will that do in this circumstance? If you don't keep reviewing and looking at every aspect of it, you're not truly researching it, you're just going in one minor direction. So Bob and I connected the power up to this with that. There was a big cone top, 5-inch round, biggest cell I've had. We left it on for how long, Bob?
Was it even on charge at the time?
Yeah, it had been previous. Well, we don't normally charge for the inside charge, so we charge in a lot shorter duration, sometimes 20 seconds. And we pull started it.
You did.
I did. And the cell was there, and I simply saw a colour change. Heard nothing, felt nothing, looked at Bob, and then looked back and realised the top was missing off the cell, and he looked up. And that cone top, they're pretty thin, they weigh nothing. It not only broke the asbestos, it fractured a wooden beam that goes through the roof, and it pushed the bottom through the beam. So
That actually travelled 5 feet, that cell top, with the pipe on it.
yeah, just...
But the cause was really nothing to do with the cell, well, except it had a little bit of hydrogen in there, but it was the engine, the short out, and it was a backfire.
Oh, yes, that's right, that's what it is. Now we're getting there. I didn't say much of this stuff in the beginning. The backfire did cause it, that's why now everywhere I say use these things. HHO flashback, they're full of glass beads that made HHO hydrogen flashback won't stop the gas release that flashback. Okay, hydrogen doesn't burn anywhere nearly as quick as when it's got oxygen in it. That's what you get from one of these cells. So proper HHO flashback arrest, absolute must. We had a cell that accumulated the hydrogen, and on my slide here, one of my slide wires just wore through on the slide when it came off the top. We had a point, I pulled the string, and I think we worked it afterwards that it sparked every couple of degrees, and one of them would have been at a point where it went straight back up the tube, bang. And well, I try to forget that, but I'm really uncomfortable with working with some of these cells now. If they don't have a flashback arrestor, I won't start the engine. I'm very lucky I wasn't killed. The force that it took to do that was just enormous. So, anyway.
Anyone that you know of had any using this
Not personally. I spoke to a guy in Western Australia some time back that claimed to have a diesel stationary for his power plant, which his son made a cell with the car ignition coil housing. So it's on the generator, pretty small. And he claimed it ran for quite a period of time. Firstly, they thought of it as using extremely little diesel because the diesel consumption went down to nothing for months. But then they realised they were actually out of diesel and it kept running. So, but I don't personally, I mean, I spoke to the guy, he seemed quite credible, but I've never had experience with diesel personally. So, anyone else? Out there?
Can we see it running?
No, I'm afraid you can't because the cell's in bits, and I discussed this with Bob beforehand. We didn't think people would let us start petrol in here, so...
We might be.
I was hoping Bob's would be going tonight. I truly was. It was so close that I was kind of dancing on
I
that.
worked pretty hard to put this one up, and I didn't quite finish. The tappets haven't been done. I've spun the motor over. The generator isn't connected up because I'm not an electrician. I've got a few other people to do a few things, but that's the only things that have to be done. Then it can run on gas. Then Stephen can experiment with a water-cooled engine. This is going to be down your place for quite a while, I think. You're welcome to use it. That's a 6 kVA generator and a 1200cc. That's a 121. It's just laying at home. I'll use that one. It's taken a few months to put it together. I thought, oh, we'll run on gas and get rid of the carby later on and just have the butterfly, because as Joe pointed out to Joe, I said, you don't really need a butterfly. And he said, I never thought about that. And it's such a simple thing. Why do we need a car rental? We don't need the butterfly. You only let the air in. So that's going to get deleted. And the aluminium fella, where is he? Couple of gentlemen there, they give me some aluminium the other day. I'll make a block up with a butterfly in it, and that's all we're going to need, hopefully. But there's other things. These gentlemen up here have got a lot of aluminium swarf. What we're hoping to do is to encase a cell with aluminium swarf to see if it holds more deuterium. And that could be an interesting thing too. But we haven't done it yet. I'm going to make up the dummy to put the aluminium cast. We've got plenty of aluminium there, haven't you? Yeah. So anyway, thanks very much, Stephen, for coming in tonight and presenting the cell and presenting your book. Sorry. The price of the book is $49.95. Not that, like that bloke come up there and said 99.9 or something. We all thought it was 99 cents, but it was $9.99. These are $49.95. And there's only, sorry.
This does oxygen and acetylene gauges if anyone's interested in it. Just on the end there.
Acetylene gauges, right.
Yeah, or bring you if anybody's interested.
Right. We'll bring that up. Look, there's a box of books here, and I'm looking after the sales of it. So come and see me after if you want one, or down the line. I've got some business cards, a pretty poor quality one because they forgot to get printed by the boss. So, right, well, thanks very much, Stephen. And any other questions? Anybody really want to present something important? Yes?
Bob, as a teaser for the people here that are new to it, why don't you mention what sort of car Joe was driving originally back in the 90s?
Well, I didn't ask him.
Didn't you?
No.
Wasn't it a Ford Escort? An RS?
That was one of them. Also the Rover V8. That was one of the first ones.
Why don't you mention some of the strange effects you noticed in the car?
Well, which one do you want?
The inertial dampening one.
Which one?
The inertial dampening effect when you had a tuned car running. Didn't experience G-forces when you went around corners.
Oh, no, that's not his car.
Wasn't it?
No, that's a Scottish gentleman. He told me where he lived, but that's an interesting story again. It's supposed to go around corners without tipping over and also get off the ground.
Yeah.
Joe had been in it, but he wasn't interested. But I won't go into all that part. That's another story. And that may come later, because I think we're playing with this sort of stuff. You're going to come across that stuff, because that's what that bloke did. He came across that stuff. But Joe, that was not Joe's car. He was not interested. But actually Joe had been for driving it, put his hands under the wheels. But I'd like to know, how did they steer it, how did they stop it, and things like that. But he said it was dead smooth over a real rough bit of corrugated bitumen. I've actually seen a bit of bitumen. I've seen the ramps which they put the tractor on the back of the ute with before it went off the ground. So some strange things, yeah. Joe's a fantastic bloke, really. He's very open. He doesn't know what it is, but he knows how to handle it, which was beautiful. And I was lucky enough to spend 2.5 days with another gentleman here. You spent, what, a week with him and been in touch with him for a long time. You've got a video later on, I hope to show, not tonight, of the dragster that Joe had so-called treated or put a cell on. And Joe showed me a different dragster film too. Very eye-opening. It's not his vehicle though. But Joe did apparently 14 different vehicles, including the diesel. The diesel, as Stephen said, must have an ignition. You must still have that spark. Joe's a very strange thing. He's a strange person. He's played with a lot of things that come across a lot of abnormalities. Victor's about abnormalities. He knows a lot of strange things out there. Well, Joe picked all this up with a cell too. There was a lot of abnormalities. And I was permitted to take 3 days of talking with Joe, and then some friends actually transposed it to computer. My wife made some books, and a few of you fellas have read these books. Well, you eventually got a set, didn't you, from another one of our members, sort of thing, in the roundabout way. Eventually you gave it back to Joe. He would know all about that anyway. Now, has anybody else got something to present now? You've got some...
Yeah, not seeing the satellite gauge there.
Right.
If anybody is interested in that, fairly good.
How much?
$25 each.
There we go. There's a buyer, is it? Oxy gauges. Oh, sorry. You're going to start the auction. So has anybody got anything else to... yes?